Hello, welcome back to another fantastic, amazing podcast from Aliens and Space Education. All about the planets at the moment. Today's focus will be about the amazing fiery twin of Earth, Venus. I'm your host, Andy, as we look at this interesting dynamic planet. Venus is often referred to as Earth's twin due to its similar size and composition, yet a very, very different evil one. So it has hellish surface temperatures, hence the evil bit, toxic atmospheres, Venus presents one of the most extreme environments in the solar system because it's highly thin. We're going to delve into the mysteries of its violent history and why it became the key focus in the search for life beyond Earth. It's interesting. Could there be life on Venus? Why do we keep looking there? So let's set our sights on the second planet from the Sun and uncover the secrets of the dynamic Venus. So let's begin by placing Venus in context of our solar system. Venus is the second planet from the Sun. Obviously, we did Mercury in the last episode. We're doing Venus today. Orbiting an average distance of about 108 million kilometers or 67 million kilometers from the Sun. This makes Venus our closest neighbor. It's slightly smaller than the Earth, with a diameter of about 12,004 kilometers or 7,521 miles, compared to Earth's 12,742. So it's 12,104, and we're only 12,742 kilometers. Not much in it. Earth is, because of its proximity and similar size, Venus is often called Earth's sister or twin because we are very, very similar in size, but very, very different. But despite the superficial similarities, Venus is a world of contrasts. Unlike Earth, Venus rotates very slowly and in the opposite direction. Hang on, it spins slowly backwards to Earth? That's weird. That's cool. That'd be interesting. A day on Venus, meaning the time it takes for the planet to complete one full rotation, because it spins so slowly, one day on Venus is 243 days. Could you be awake 243 days? That's a long day. Yet what's really weird is a year on Venus, so the time it takes to do one orbit around the Sun, is 225 days. So a day is longer than a year, and it's going backwards. Wow, that's slow. So every day would be your birthday. You'd have a birthday every day because the day is so long. This means that the day on Venus is actually longer than a year. And if that's not strange, because it's retrograde or rotation, which means it goes in the opposite direction, the Sun would appear to rise in the west and set in the east on Venus, the opposite of what we experience on Earth. It rises in the east and sets in the west. So imagine the Sun going backwards across the sky. That is highly unusual and highly strange. But it does happen. However, how much of that would you see? Because Venus has a thick, toxic atmosphere. Would you be able to see through the clouds to see the Sun? One of the most defining characteristics of Venus is its thick, toxic atmosphere. Venus has a very dense atmosphere composed mainly of carbon dioxide, which is about 96.5%, with traces of nitrogen and sulfur dioxide. The dense atmosphere creates sulfur pressure about 92 times greater than the Earth. To put that in perspective, it's the same pressure you'd experience if you were 900 meters or 3,000 feet underwater on Earth. So standing on the surface of Venus would feel like being in the deep ocean, but without the water. So do you really think you'd be able to see the sun? So it could be very, very dark there. They would get little light through the breaks in the cloud, but it'd be dark. And you'd have all this pressure on you as well. It would crush you like a tin can. So Mercury, pressure, not the gravity, the pressure would be highly dangerous. The thick atmosphere also traps all the heat through a runaway greenhouse effect. Now we know of a greenhouse effect because it's melting our polar ice caps here on Earth. So by understanding Venus, maybe we can prevent Earth having the same thing. Because it's a runaway greenhouse effect, this makes Venus the hottest planet in the solar system. Its surface temperature, on average, is 467 degrees C or 872 degrees Fahrenheit. Because it's this thick pressure and atmosphere traps the heat in. So the sun is sending heat in, as we know, and because its surface is so thick of all sorts of stuff, it's creating a runaway greenhouse effect that makes it hotter and hotter and hotter and gets this. Now, because of its 467 degrees Celsius, that is hot enough to melt lead, a very strong, highly heat-resistant material. But in Venus, it's not very good. This intense heat, even distributed across the planet, so there are no significant differences between day and night temperature, or between the equator and the poles. Venus's clouds, which trap the heat in, which are composed of sulfuric acid, add to the infernal environment, reflecting sunlight and shrouding the thick planet in a yellowish clouds that hide its surface from view. So even though sunlight does get through its clouds, a lot of it is reflected away. If you felt glass, and any glass, or safely, it gets hot in sunlight, or it used to get hot in sunlight, not so much now. But if your metal pipe or something, things get hot in the sunlight. Well, its atmosphere is getting the sunlight hitting it. Just because it's reflecting it doesn't mean that heat isn't heating up the atmosphere as well. And these things are happening. Remember, Venus looks yellow to us because of its thick clouds, so it's very hard to actually see the surface of Venus. These clouds and thick atmosphere have made Venus a challenging target to observe. Optical telescopes on Earth cannot see through the clouds, so for centuries Venus was a planet of mystery. It wasn't until the development of radar technology that we began to peek back the layers and glimpse the surface of Venus. It's because of Venus we discovered new ways to use radar technology and see what else we can discover. And we used it to look at Venus, to figure out its surface. So what is the surface of Venus like? What lies beneath the clouds on this world is both fascinating and hostile. Venus's surface is relatively young in geological terms, with estimates suggest it's about 300 to 500 million years old. The dinosaurs are older than that. Its youth is likely due to catastrophic event or a series of events that resurface this planet, possibly through widespread volcanic activity. Something bad happened to Venus between 300 and 500 million years ago for it to have a brand new surface. Could it be linked to something that happened on Earth, or could it be something new? Could another asteroid that flew through our solar system that wiped out our dinosaurs, could it have a twin that missed Earth and then hit Venus? Maybe. Could be. We never know. Indeed, Venus is covered with vast plains of volcanic rock. More than 80% of Venus's surface is composed of smooth volcanic plains, and it boasts some of the largest volcanoes in the solar system. Remember, Mars has Mat Moons, which is 8 kilometers or 5 miles taller, slightly taller than Mount Everest. Now, Mars is bigger. The highest volcano on Venus is Matterhorn, which stands 85 kilometers, slightly taller than Mount Everest. So even though Mount Everest is not the largest peak in the solar system, Venus has large volcanoes. Mars has even bigger. Venus also has a large dome-like formation called corona, which are unique to the planet and likely formed by upwelling of hot material from the planet's interior. This geological feature indicates that Venus has been and perhaps is still geologically active, although it doesn't have the same tectonic plates which find on Earth. So something is happening below the surface. Something is making the surface swell a little bit somewhere. And will that explode out? Will that create another volcano? What will happen? How high will that blast? Will that break through the atmosphere? We don't know. But something is happening there. But because of its thick atmosphere, because it's so toxic there, we can't send any probes there yet. Interestingly, radar images of Venus have revealed mysterious pancake-shaped domes, which are likely volcanic in origin. These domes are thought to form when thick lava oozes onto the surface. It spreads out in a uniform layer. Unlike Earth, where water plays a crucial role in shaping the landscape, Venus features are purely the result of volcanic activity and surface deformation. The easiest way to describe this is when you look at the beach, at a sandy beach, you see the waves come up, it knocks things down and then it makes it all smooth. But we have tectonic plates moving as well, and that can cause earthquakes and things, volcanoes and other things to happen. And it's all moving. On Venus, that doesn't happen. There's no tectonic plates, there's no water. So when the lava flows from its core out of a volcano, there's nothing stopping it. So it just goes like one long sheet of paper, spread across, and it's all smooth and even. There's nothing to make it bubble up, nothing to fight against. It's just there. So there's nothing interfering with it, which is really cool. Another interesting aspect of Venus's surface is the presence of tesserae, which are highly deformed regions that intersect each other, creating a tesselar pattern. These tesserae are some of the oldest surfaces on Venus, with their formation is still not fully understood. They may represent areas where the crust has been compressed, twisted, and folded in a way that is unique to Venus. There are patterns on Venus and things happening on the surface that happen nowhere else, to our knowledge, in our solar system or on any other planet that we know of. Could be. We're still discovering more and more planets, but at the minute, Venus is really weird and unusual and very, very fascinating. Despite the intense heat and pressure on Venus, there is evidence to suggest that some volcanic eruptions may still be occurring today. We believe, from what data we've received, there are still volcanoes exploding on Venus. Data from the European Space Agency's Venus Express mission showed localized temperature increases on the surface which indicate recent volcanic activity. So there has been recent activity on the planet, and we have seen it. We're seeing the temperature fluctuations. So because it's spiked in one area, it means there's lava flowing. If Venus is still volcanically active, it would make one of the few places in the solar system alongside Earth and Jupiter's moon Io where we can observe volcanism. We can still, even on Io, because that could help with the building blocks of life, heat. So could there be life on Venus? Not as we know it. Phosphine and other mysteries in the search for life. Given Venus's extreme conditions, it seems like the last place you'd expect to find life. However, recent discoveries have ignited a debate about the possibilities of life on Venus. In 2020, scientists announced the detection of phosphine gas on Venus's atmosphere. Phosphine is a molecule that on Earth is primarily mostly produced by a biological process, meaning living organisms. The discovery of phosphine on Venus was surprising because the planet's surface conditions are so inhospitable. This has led to speculation that life exists on Venus. It might be in the upper layers of the atmosphere where the temperature and pressure are less extreme. What flies in the sky? Birds. But if they can't land, how do they stay up there? Could it be fish flying in the surface, flying in the clouds? They can handle the pressure and breathe out phosphine. We don't know what could be in the surface of Venus, but could there be life from the clouds? Could there be a biological process going on that we're unaware of? This discovery is still under scrutiny. We're still confirming everything and trying to find the answers. Some scientists argue that phosphine might not be there at all, or that it could be produced by an unknown chemical process rather than by a living organism. Now, we don't know of another scientific way to produce phosphine other than biological. But we don't know everything. Could there be a way to produce phosphine without organic material? Despite the ongoing debate, the discovery has prompted renewed interest in Venus, with several space agencies planning missions to investigate more. We're sending more probes to Venus. Yay! That's cool. If life does exist in Venus's atmosphere, it would be microbiological or likely to adapt to survive in extremely acidic or harsh conditions. So they think it won't be similar to fish, it'd be tiny microbes. However, how are we here? We evolved from tiny microbes. Could there be bigger things there? Who knows? And could these things live on the surface or somewhere else? So we're looking further. This has led to a comparison of the exomorphs on Earth, microorganisms that live in the environment previously thought to be inhabitable, such as acidic hot springs or deep sea hydrothermal vents. The idea that life could environment challenges our understanding to the limits of life and expand the potential of finding life elsewhere in the solar system. Now we have gone to hydrothermals under the sea, and we have discovered microbiological organisms growing right by thermals. So the water's freezing on one side, hot on the other, and there is things growing near the thermals because it is an hospital atmosphere. Yeah, it's doing it. There is a river in Spain that is highly acidic. You can't walk through it. You'd burn your feet, burn your toes. You have to wear wellies. But once you use those wellies, they're done. They've got holes in because the acid, the acidic, would melt your boots, melt your welly boots. But they have discovered live bacteria in the river that is highly acidic, which means there is a possibility of microbiological life on Venus. Doesn't mean it's going to look like us. It could be completely different. We don't know, but it is a very strong possibility that there is something there. What it looks like, how big it is, we don't know. So please don't go jumping. There's aliens on Venus. We don't know. It could be. It's a very strong possibility. Now, how has Venus influenced Earth? Excuse me. Let's take a moment to appreciate the significance Venus has had on human culture. Venus has been observed by civilizations for thousands of years as a bright object in the sky after the sun and moon. And because of this, it's been associated with various deities and myths across culture. In Roman mythology, Venus was a goddess of love and beauty. equivalent to Greek goddess Aphrodite. The planet's bright appearance in the sky made it a symbol of beauty and brightness, and the ancient Babylonians associate Venus with the goddess Ishtar, who is also linked to love and fertility. The Mayans had a complex calendar system that included cycles of Venus, and they associate the planet with. They even timed certain events, such as war, based on Venus's position in the sky. So Venus has had a massive impact. Even further, in the East, Chinese refer to Venus as the metal star, associated with the element of metal in their five-element system. In Japanese, on the other hand, they called Venus Kinsei, which means gold star, reflecting its bright golden appearance. I apologize if I pronounced any of that wrong. In modern times, Venus has continued to captivate the imagination and has been the subject of countless science fiction stories, and often portrayed as a world of sweltering jungles and alien creatures, an image that persistent until we learn the true nature of the hostile environment, despite Venus remained a symbol of love, beauty, and mystery in our culture. So until we looked at it, used radar to look at the surface, we honestly thought there could be jungles there. We thought it could be full of life and everything like that. And then we used radars and we discovered, nah, that's not what's there. We got it wrong. But now we know what's there. Now we know there are things there. We are now looking to see if there is potential for life there, as we different to what we are, but there could be. And that's what makes Venus so fascinating. The explorations of Venus, however, have been just as fascinating. Venus was the first planet to be explored by a spacecraft. It has a long history of space missions, beginning with the Soviet Union's Ventura program. Ventura mission, which spanned from 1961 to 1984, was a series of Soviet probes designed to study Venus. The early missions faced numerous challenges, as extreme conditions on Venus destroyed several spacecrafts before they could return data because it is so harsh there. However, later missions were more successful. Ventura 7 in 1970 became the first spacecraft to transmit data from the surface of the planet. Ventura 9 and 10 sent back the first images of Venus' surface, revealing a barren, rocky landscape under the prevalent cloudy sky. So it's the Soviet Union, the Russians, that got the first images of the surface. The Russians did it, not the Americans. Ventura lander also provided valuable data on the composition of Venus' surface and atmosphere, confirming its high temperature and pressures. These missions were groundbreaking, providing the first direct measurements of Venus' environment and setting the stage for future exploration. In the United States, NASA launched Mariner and Pioneer missions. Mariner 2 in 1962 became the first successful flyby. It never landed, it flew by Venus, providing data on its atmosphere and confirming Venus has extremely high surface temperature. Near Venus in the late 1970s included both an orbiter and a set of probes that were dropped into the Venus' atmosphere, providing detailed profile of its composition, structure, and dynamics. So both Mercury and Russia had a little race to see who could discover more about Venus. Who do you think won? I think Russia's won because they actually landed on the surface and got some really good data. They landed 3 times. Americans didn't. We might get in trouble. More recently, the European Space Agency, Venus Express, which operated from 2006 to 2014, conducted the most extensive study of Venus' atmosphere, surface temperature, and volcanic activity. Venus Express confirmed Venus' atmosphere is dynamic and variable, with rapid changes in temperature and wind patterns. It also provided evidence of the possible volcanic activity, suggesting that Venus still might be geologically active. No, we don't believe there's titanic plates. Everything we said there isn't, but we have been wrong before. We thought there were jungles there. There isn't. There could be titanic plates. We don't know. We don't believe there is. But the wind system, think about the winds here we have on Earth. They're constantly changing. But what causes that change? That is caused by pressure and the movement of the planet. And other factors as well. So winds, etc. There's a lot of different factors that produce wind. But one of the key factors is the pressure. The pressure changes means the stronger gales. So how do we measure the weather patterns on Venus and get to understand them better? It's so we need to look at and discover, and not only by understanding the winds, we could understand more about the surface and what creates these changes could lead to more understanding about Venus and learn about, well, hang on, there's a cold patch here. It's not all hot, not like we think it is. So we need to look more at these different things. We need to look more at the surface. We need to be able to land on the surface and deal with that immense high pressure, intense heat, sulfuric acid, a sulfuric atmosphere that's highly toxic and dangerous. We have a lot to learn, a lot to discover. And plus we've got to land somewhere where we're not going to land on top of a volcano and get blown away or melted by its lava. There's a lot we have to figure out. Maybe you can come up with something. But also, by studying its clouds in the higher atmospheres, maybe there is something there that is living in the clouds, swimming like fish or something. We don't know. So what's next? The next big step in Venus's exploration is the upcoming mission planned by NASA and other agencies. NASA's Da Vinci Plus and Ventris missions are scheduled to launch in the 2020. Da Vinci Plus will analyze Venus's atmospheres in an unprecedented detail, focusing on the composition and structure, and even sending a probe through the thick clouds to the surface. Ventris will use radar to map the surface of Venus in high resolution, helping us to understand its geological history and tectonic processes. So one's going to stay up there, one's going to go down, and they're going to talk to each other, and they're going to try and figure out what's going on and try to understand it. Whether they'll figure something out, we don't know, but it's going to be interesting. And to get a high resolution image or images of the surface, drive around and discover it. Hey, they did it with the rover, they can do it on Venus. It's worse, but they know how to protect it. They should be able to do it. India, on the other hand, Indian Space Research Organisation, ISRO, is also planning a mission called Shakura-1, I apologise if I pronounced that wrong, which is a study of the planet's atmosphere and surface. These missions, combined with the renewed interest of Venus, follow the phosphine discovery. It promises to unlock new insight into our neighbouring planet and perhaps even answer the question of whether Venus could or is harbouring life and what type of life it is, if it's got any. These missions are happening and going ahead. What will they discover? What would you like it to figure out? Could be interesting. Understanding Venus helps us understand Earth and beyond. Studying Venus is not just about studying our neighbour planet. It's also understanding Earth and broader conditions that make the planet habitable or inhospitable. Venus and Earth started out as similar sizes, composition, and likely similar amounts of water. But something happened on Venus that led to an extreme greenhouse effect we see today, while Earth remained habitable. What changed on Venus? We need to discover this. By studying Venus, scientists hope to learn more about the processes that can help lead to such divergent outcomes for planets and the planets start off similarly. This is known as crucial as we search for exoplanets, planets around other stars that might support life. Now, we've discovered over 5,000 planets outside our solar system and exoplanets. Some, when we say, are in hospital, we can't live there because of the extreme conditions. However, Venus has extreme conditions and it's hospitable. If we discover life there, whatever form it may be, that means these planets we've written off saying, we might have to turn around and say yes to and go back and look at them again. By understanding Venus, we can better identify which exoplanet might be more Earth-like and which might be more Venus-like and which might be in the future more Earth-like and more Venus-like. Because the Earth-like ones could have something happen to it and turn to Venus, or vice versa. So we need to discover both. Additionally, Venus serves as a cautionary tale about the impact of greenhouse gases on the planet's climate. The runaway greenhouse effect that occurred on Venus is a stark reminder to the potential consequences of unchecked global warming on Earth. If we don't want to lose this planet, and we don't want a thick atmosphere to keep the heat trapped in and melt the ice caps and make this planet underwater, we have to do something. We have to understand what's going on. By studying Venus, it helps us. However, we still have to do the work here on Earth to protect our planet. So it does help us understand our own planet. It does help us do better. I'm afraid this is where my notes run out. We've come to the end. I'd like to thank you for this exploration of Venus. I hope you really enjoyed it. We find that this planet is often overlooked in favour of Mars and the other planets. But Venus has a lot to teach us. It's a world of extremes, heat and pressure and chemistry. It challenges to understand the planetary sciences and the conditions that support and destroy life. With new missions on the horizon, we are poised to learn even more about the mysterious planet. Who knows what secrets Venus still holds, and perhaps in the coming decades we'll finally unravel the mystery of Earth's fiery twin. Thank you for joining me. This has been an amazing episode. I've really enjoyed producing it, creating it for you. I really hope you've enjoyed it as much as I have. Please subscribe, rate, leave a review, share, join up, go to my Patreon, back me. Anything you can do to show your support, please do it. The next episode, we're venturing out a little bit further, and we're going to look at something a little bit different. According to my notes, we have planet Earth. I wonder why that is. Obviously, I'm doing it in order, so of course it's going to be Earth. Keep looking to the stars, keep looking up, keep asking questions. Go to my website. If you have any questions, please get in touch. I'm happy to help you learn and expand your knowledge. I really enjoyed this. Keep looking up. Thank you.